In this presentation, I will teach you serial input, parallel output, shift register and parallel input, parallel output, shift register. We have already completed serial input, serial output mode in the last presentation, and this is the circuit. As the name suggests, we want to enter the data in serial manner. And I took one example in which I had the 4-bit number. This is the 4-bit number that I wanted to store in this SIPO register, and for this I have to introduce this LSB to D3, and then I will introduce this one, then this one, and finally the MSB, the most significant bit. We are operating, or we are entering the bit one by one because we are having the serial input mode. And in this shift register we also have the serial output mode. So the output is taken from Q0, and the data that is being shifted with the clock pulse is taken out from here. So this one is our serial output. So this is something we have already completed, and we also obtained this waveforms. And in this you can see, before the first falling edge arrives, because all the flip-flops are negative as triggered, all the changes will occur for the falling edge. The values for the output Q3, Q2, Q1 and Q0 is 0. You can see it is 0. So we have the value for the output of the flip-flops as 0, 0, 0, a 0. And from here you can clearly see the output of the shift register. Actually this will come in package. This whole circuit will come in a package like this, and you have the output as Q0. Whatever be the output, Q3, Q2, Q1 are the internal outputs. It will not be reflected outside this IC. You will have Q0 only. So what is the value of the Q0 before the first falling edge? It is 0. Okay, so you have to just follow Q0. I am going to explain you very important point here. That's why I am explaining it again. The point is, the number of clock pulses required to store the data is 4. 1, 2, 3, 4. So there are 4 clock pulses required to store the data, but these 4 clock pulses are not sufficient to have the data outside. We need more clock pulses to have our data out. So that's what I'm explaining you. So I have Q0 as 0, and again in this you can see Q0 is 0. So Q0 is 0, and for this clock pulse Q0 is 0 again. For this clock pulse Q0 is 0, and finally our LSB is detected and we have Q0 as 1. So now our data is coming out, and we can write it as 0, 0, 0, 0. This is the LSB. Then again we have 1, 1, and finally the MSB. So in this way we have our data as 1, 1, 1, 1 output from Q0. So definitely we require more than 4 clock pulses to have our data out from the shift register. So this is a drawback because we require more clock pulses. And in serial input parallel mode, what we have the serial input of data. This thing will remain the same. The data will be fed in serial manner bit by bit, but the output of the data is not like this. It is not serial. So what changes I need to do, I'm going to show you. I will just have Q3 as my output, Q2 as my output, Q1 as my output, and Q0 is definitely my output. So instead of having this one output in the IC, I have 4 outputs. And what is the change? Let me show you. Once we are here, once we have stored the data that we want to store, and this data can be definitely 1, 0, 1, 1, 0, 0, 1, 1, whatever you want to store. I have selected to store 1, 1, 1, 1. And once we are at this point, what is the value of Q3? Q3 is 1, Q2 is 1, Q1 is 1, Q0 is 1. So let's see what we have in this circuit. Q3 is 1, Q2 is 1, Q1 is 1, Q0 is 1. So you can see we have our stored data as the output as soon as we pass the 4th clock pulse. So definitely we don't require more clock pulses to have this data out of this IC. So this is the advantage of the serial input parallel output. And the real life use of this thing is when you want to have your serial data in parallel form. For example, the data is coming in serial form like this. and you want it in parallel. So what you will use serial input parallel output shift register, and you will have the same data in parallel manner. Okay, if it was B0, B1, B2, B3, so we have B0 like this, B1, B2, B3. So this serial data is converted to the parallel one, and I hope you know the working of this circuit, because we have discussed it in the last presentation, and I'm not going to explain how these values are being changing depending upon the properties of the D flip-flop. So this is all for the serial input parallel output, and definitely to store the data we require 4 clock pulses in this also. So in serial input serial output we require 4 clock pulses to store the data, and in serial input parallel output also we require 4 clock pulses to store the data. But to get out the data we need more number of cycles or more clock pulses in case of serial input serial output. So it depends upon your use. It is not like we don't use serial input serial output. It is required for some particular operations, whereas SIPO, serial input parallel output, is required for some another particular operations. Now we can move to parallel input parallel output mode. It is a very simple configuration in the shift registers, and it is one of the most basic thing that you have to know in this. And I will call parallel input parallel output as the storage register, and I will also call it as buffer register. I told you that depending upon the application we divide the registers into two types. The first one is the shift register and the second one is the storage register. So storage register is nothing but the parallel input parallel output shift register, and we also call it as the buffer register. So let's see what it is. For the falling edge, what we do, if there is a clock and for the falling edge okay, so the data that you want to store, let's say I want to store 1 0 1 1. So what I will do, I will make D3 equal to 1 before this clock pulse arrive. This is a good practice to do, and we always do it. Before the clock pulse arrive, we just make the input that we want to make it. And in the same way, I will make D2 equal to 0 because it is 0, D1 equal to 1, D0 equal to 1. And once this falling edge is there, once we have the negative edge triggering, the flip-flop will be operational. And we very well know that in case of D flip-flop, if D is equal to 0, this implies that the next state Qn plus 1 is also equal to 0. If D is equal to 1, it implies that the next state is also equal to 1. So D3 is 1. So the data that is going to be stored in this flip-flop is 1. In the same way, here we have 0, 1 and 1. Now simply make the clock equal to 0, and this will imply that whatever be the value of D, it is don't care, and we have Qn plus 1 as Qn, and Qn is nothing but the stored value, the previous value, or you can say that the stored value or the previous state is the good thing to call. And the previous value is 1 for flip-flop 3, 0 for flip-flop 2, 1 for flip-flop 1 and 1 for flip-flop number 0. Now you have stored the data. Just take it out in parallel manner. Q3 is 1, Q2 is 0, Q1 is 1, Q0 is 1. So we wanted to store 1011. We stored 1011 without having any problem, and we have 1011 as our output, and this will be the output. And once you introduce the clock, and when we have a falling edge, the flip-flop will be operational, and whatever be the value here is again going to be stored. For example, now we have 1 0 0 0, so these values will be overridden, and we have 1 as the new value, 0, this one will now become 0, and this one will now become a 0. So we have 1 0 0 0. So this is a very simple operation. That's why we call as buffer. By buffer I mean whatever value I give, I have it as the output. Okay, If I give 1, I have 1 as the output. If I give 0, I have 0 as the output. So it is acting as the buffer. That's why we call it as the buffer register, and definitely it is acting as the storage register. If you want to store 101 or 1, just give it, remove the clock, 1011 will be there, and we are just storing the data until we want to store it. And this is the parallel input and parallel output, because the input is in parallel manner. In the last case, we have the input in the serial manner. We are giving the input bit wise. We are first introducing the LSB and then go all the way to MSB, whereas in this case we introduce the LSB here, we introduce the next significant bit here, then again the next significant bit here, and finally the MSB here. We are introducing the bits in parallel manner and we are getting them out in the parallel manner. So these two configurations are very easy but very important. And what about the storage of data? How many clock pulses we require to store the data? It is simply 1. So we require 1 clock pulse, to store the data, So definitely the storage of data is very fast as compared to the serial input parallel output and serial input serial output. In these two cases we require 4 clock pulses. In the next presentation we will study parallel input serial output, a very important presentation, and then we will study bidirectional shift registers and universal shift registers. So see you in the next presentation. If you have any doubt, you can ask in the comment section.